Hello everyone. Today we are going to be working on solving some quadratic equations over the complex numbers. Now, we know generally when we have a quadratic written in the form of x squared minus a squared, we can rewrite this or factorize this as a difference of two squares. So this would be factorized into x minus a times x plus a. The first thing to learn when we're factorizing some quadratic equations over the complex numbers is that we can also apply this rule to your complex numbers. So, for example, if we have an equation written as z squared plus a squared, this can be rewritten as z squared minus negative a squared. We also know that this minus over here, can be written as the square root of negative 1 squared times a squared. So this is essentially rewritten as z squared minus I squared times a squared. Again, if I neaten this up a little bit, it can be written as z squared minus I a squared. Now, this form is quite similar to what we had over here. So we know that this sum of two squares can now be written as a difference of two squares. And so this can be factorized into z minus ai times z plus ai. Now let's try this with some actual numbers. So let's try to factorize z squared plus 16. Again, we know that z squared plus 16 can also be written as z squared minus negative 16. And we also know that this negative 1 over here, so negative 1 times 16, so the negative 1 over there, so this negative 1 can be rewritten as the square root of negative 1 squared times 16. We also know that the square root of negative 1 is essentially I, so we can write this as minus I squared times 16. So we're left with z squared minus 16i squared. Now we also know that the square root of 16 is 4. So this can be rewritten as 4i squared. So this 16i squared can be rewritten as 4i all squared. This can then be easily factorized using our difference of two squares. This is factorized into z minus 4i times z plus 4i. Let's try this with another example, only this time we have a 2 out the front. So, for example, we've got 2z squared plus 6, and we're trying to factorize this. Now remember, the very first step to do over here would be to factor out the 2. So we'll factor out the 2, leaving us with z squared plus 3 within our brackets. So the reason that we want to factorize out the 2 is because we want to be able to use our difference of two squares to factorize this equation. And we cannot do that with a coefficient out the front of this term. Okay, so let's continue. Just like before, we can rewrite our z squared plus 3 as minus negative 3. We also know that our negative 1 in here, so our negative 1 here, can be rewritten as I squared times 3. So this can be rewritten as 2z squared minus 3i squared. Again, we want to be able to clearly see the square root of this. So taking the square root and then squaring this term, we would get 2 times z squared minus the square root of 3i all squared. Now we can use our difference of two squares formula to factorize. So this would become 2 times z minus square root of 3i times z plus square root of 3i. Now, the second method that we could use to factorize our quadratic equations is by using our completing the square formula. So let's have a go with this equation here. So we've got z squared plus z plus 3. If we were to complete the square, then we would take the value of our b over here and divide it by 2. So we would go 1 divided by 2 squared minus 1 divided by 2 squared plus 3. Looking at this part of this equation, we know that it can be simplified into z plus a half squared, and simplifying this part of the equation, we know this will become minus 1 over 4 plus 3, which is equal to z plus 1 over 2 squared plus 11 over 4. Even here, we can convert this to our difference of two squares form. So what we can do is we can manipulate this equation to write it in the form of the difference of two squares. So instead of having a plus over here, we will turn it into a minus and write this as minus negative 11 over 4. Again, using the same logic as before, our negative 11 over 4 can be expressed as I squared times 11 over 4. So this equation can be rewritten as z plus 1 over 2 squared minus 11 over 4 I squared. Now we can use our difference of two squares formula to factorize this further. So here is our first square, and here is our second square, only we can rewrite this a bit better to make it a bit clearer. So let's rewrite this as the square root of 11 over 2 times I all squared. So let me rewrite all of this. So using our difference of two squares knowledge, we know that this equation can be factorized into z plus 1 over 2, so this is your first square, minus square root of 11 over 2i, and our second factor would be z plus a half, so again from over here, this time plus square root of 11 over 2i. Okay, let's try this with one more equation, again with a coefficient out the front. So we've got, let's try 2z squared minus z plus 1 as our example. Okay, same thing as before. We're going to first factorize out this 2 so that we can then continue to complete the square. So we're going to factor out the 2, leaving us with z squared minus 1 over 2z plus 1 over 2. Now we can continue to complete the square for this part of the equation. So let's do that now. So we've got z squared minus half z, and we're going to take our b, which is negative a half. So negative a half over 2 all squared minus negative a half over 2 all squared plus a half from here. Okay, looking at this part of our equation, we know that this can be factorized into z minus 1 over 4 squared. So z minus 1 over 4 squared. So this can be rewritten as negative 1 over 4. And that is all squared. Simplifying the rest of our equation over here, this should give us minus negative 1 over 4 squared plus a half. And if we continue to simplify this, we get z minus quarter squared over here as before, minus 1 over 16 plus a half. So this can simplify to 2 times z minus 1 over 4 squared plus 7 over 16. 7 over 16. So that's from over here. That gives us 7 over 16. Again, using the same logic that we used before, this part of the equation can be rewritten as minus negative 7 over 16. And we know that our negative 1 over here can be written as I squared times 7 over 16. And if we were to write this a bit clearer, it can also be written as the square root of 7 over 4 times I all squared. So I'll bring the rest of this equation down as well. So this would become 2 times z minus 1 over 4 squared minus brackets square root of 7 over 4 I all squared. Okay, so again, we can use our difference of two squares formula now. So from over here, we would get our z minus 1 over 4 minus this part of the equation, so minus square root of 7 over 4i. And for our other factor, we would get z minus 1 over 4, again from this part of the equation. And this time we would have plus square root of 7 over 4i. So we now know that our factorized form of this equation can be written as 2 times z minus 1 over 4 minus square root of 7 over 4i and z minus 1 over 4 plus square root of 7 over 4i. Now, our very last method that we can use to solve our quadratic equations would be to use the quadratic formula. So the last method is to simply use the quadratic formula. So again, let's try this with an example. So let's use z squared plus z plus 3 equals 0. Our quadratic formula can be written in the form z equals negative b plus or minus square root of b squared minus 4ac all over 2a. Your a is the invisible 1 over here, your b is the positive 1 over here, and your c is the positive 3 over here. So if we were to substitute in these values, we would get z equals negative 1, so the 1 is from the b over here, plus or minus the square root of b squared, so that would be 1 squared, minus 4 times a, which is 1, times c, which is 3, all over 2 times a, which is 1. Again, just using algebra to simplify this, we get negative 1 plus or minus square root of 1 minus 12 all over 2. Continuing to simplify this, we would get z equals negative 1 plus or minus the square root of negative 11 over 2. We also know that our square root of negative 11 can be written as square root of negative 1 times the square root of 11, all over 2. Our square root of 1 is the same thing as writing I, so this becomes negative 1 plus or minus square root of 11i, all over 2. So your solution to this equation would be negative 1 over 2 plus or minus square root of 11 over 2i. And if we wanted to factorize this equation, well, we already know our solutions, so putting this into our factorized form should be very simple. So this would be z minus negative a half plus square root of 11 over 2i and z minus negative a half minus square root of 11 over 2i. Now we can expand this out just to make it a little bit simpler. So let's just make this a little bit neater. So we've got z plus a half minus square root of 11 over 2i times z minus a half plus square root of 11 over 2i. So here is your factorized form of the above equation. Okay, hopefully this gave you a bit of an overview on how to solve quadratic equations over the complex numbers, remembering that our 3 methods to do this would be to use our difference of two squares rule, you can use your completing the square rule, or we can use our quadratic formula. As always, let me know if you have any questions, otherwise I will see you next time.